So my name's Will. I work on the developer relations team at Neo4j. That means that, among other things, I spend a lot of my time trying to make sure that users are successful with using Neo4j. So feel free to ping me on any of these channels. Love to chat with you at any point. So let's look at our agenda for today. So in working with users, I've come to realize that there are a lot of different ways to go about importing and modeling data in Neo4j. So I thought it would be a good exercise to take a non-trivial data set and do sort of a survey of the different methods and tools that we have at our disposal for importing this data into Neo4j. So that's sort of the goal for today, is to work through one data set, which we'll talk about in a minute. We'll talk about how to come up with a graph model for this data set that's relevant for our domain. Then we'll look at some different options that we have for importing data into Neo4j. So if you've ever imported data into Neo4j, you've probably seen load CSV in Cypher, for example. Maybe you've seen the import tool, which is a super performant way for importing large data sets in CSV format. Maybe you've seen some of the APOC procedures for importing, say, JSON, and maybe you've seen some of our language drivers for sending Cypher queries to Neo4j. So these are the things that we're going to cover in more detail, all with this example of how we would import a single data set. So all the code that I'm going to go through today is on GitHub in this repository. And if you're reading this, we're sort of giving you a hint on what data set we're going to be working with. So let's go ahead and take a look at the data. So the data set we'll be working with today comes from Yelp. If you're not familiar with Yelp, it's a business review site, I guess is maybe a good way to describe it. So it has information about lots of businesses, restaurants, grocery stores, things like this. Users can sign in and post reviews of these businesses. So it's very helpful when you want to know what's the best steakhouse in San Mateo that my friends are liking. You know, what are sort of the reviews of this restaurant, and so on. And there's a lot that goes into to what powers Yelp, but every year they have what they call the Yelp Dataset Challenge. So every year they release a subset of their global data, and they challenge folks to basically just do something interesting with that data. So let's go to the site here and take a look. And so this year they've released data on, I think, 11 cities. There we go. Data on 11 cities worldwide, some in the US, some in Europe as well. And as you can see, just looking at the size of the data, you know, it's not a trivial data set. There are 4 million reviews, about 1 million tips. So these are sort of users offering their suggestions for how to have a good experience. About 1 million users and 140,000 businesses. So you know, it's not a ginormous data set, but it's not tiny either. And so they challenge folks to do, you know, can you do some natural language processing on the reviews? Can you, say, from the text of the review, predict its rating? Can you do some social graph mining? So can we figure out who are the influential trendsetters around a certain topic, this kind of thing. And they've done this, I think, every year for the past 8 or 9 years, and some really cool academic papers have been published coming from this. So let's just take a look here at the format and the content of the data set. I should say, by the way, you can download this data set just by going to the site, yelp.com/dataset_challenge, and click on Get the Data here. So it's licensed in a manner that it's okay to use for sort of research and purposes, but not to redistribute. So you have to grab the data from Yelp. So now, if we look at the format of the data here, is we have a few JSON files. So we have one for businesses, one for reviews, one for users. We also have check-ins, tips, and then one for photos. We're not going to do anything with the photos today, although this looks like a very interesting data set. They've run some of their images through image classification algorithms, come up with different labels for lots of the images, which is something really interesting maybe we can explore going forward. Anyway, so that gives us an idea of the type of the data that we're going to be working with. So let's jump back to our slides here and talk about how we can come up with some graph data model to represent our data. So we saw sort of roughly the type of entities and JSON files that we're going to be working with. But to work with these in Neo4j, we need to create a graph data model, or a labeled property graph model specifically, to represent our data. So nodes in the graph model are the entities or the objects. They have one or more labels that describe the type or the class of the node. This is where the labeled and the labeled property graph model comes in. And each node can have one or more key value pair properties. Each node can have one or more relationships that connect nodes. Relationships have a single type, and they can also store key value pair properties. Relationships also have a direction. If you think of this in sort of language or in English terminology, well, nodes are the nouns. Adjectives that describe the nouns, these are your key value pair properties. Relationships are the verbs, and properties on the relationships are the adverbs that describe the relationship. So this is how we want to think about our graph model going forward. And I want to spend some time talking about how we can go through the data modeling process to create our data model before we start importing. Because really, creating your data model is the first approach when we start to work with data in Neo4j. And really, I think it's important to note that graph data modeling is really an iterative process. I think of it as a very agile process. But there's roughly these steps of identifying the entities in the graph. These are our nodes, and then figuring out what properties are relevant for those nodes, and identifying if we have any unique IDs. So do we have some property or combination of properties that uniquely identify a node? And then we want to identify what are the connections, which are going to be the relationships, and then we sort of repeat this process as we think about the type of questions that we want to ask of our data. And there's a very handy tool that one of our engineers wrote a long time ago that's still very useful, simple but useful tool called Arrows. So I want to use this Arrows tool to go through the process of creating a data model for our Yelp data set here. So let's go ahead and do this, just going through these JSON files. So arrows works, we can add nodes, and then double-click on the node to specify some information, mainly label and properties about the node. So starting off here, well, we have a business JSON file, so we know that business is going to be an entity or a node in our graph. Now looking at the properties that are relevant here, well, we have a business ID. This is the thing that's going to uniquely identify our business node. And then we also have a name. That's going to be a string as well. We have an address, so other things we can store as well that will be useful. Longitude and latitude. We can do some things with our spatial extension with Neo4j perhaps. Average stars, review count. These may be useful as well. And now we have categories. So I'm going to say initially here that categories could potentially be an array of strings. So we could store an array of strings as a property on our business of the categories that are relevant for this business. So that would be one potential way to do this, but we could alternatively model category as a node. And this, I think, is a really common question that comes up in graph data modeling, is when should something be a node versus a property? And I think the answer to this question is largely, at least the way I look at it anyway, if you ask yourself the question, can I discover something useful or meaningful by traversing through this thing if it were a node? So if we chose to make category a node instead of a property on each node, could we potentially discover something useful or meaningful? Well, I think the answer to that question is yes. So imagine the case where we're generating restaurant recommendations. We may want to traverse out from restaurants that a user has rated highly to find similar restaurants by traversing the graph. And one way we can define that similarity is restaurants that share a category or multiple categories. And if we have categories modeled as nodes, we can do this traversal very efficiently in Neo4j, taking advantage of this concept of index-free adjacency, basically that traversing the graph is very, very fast. So I think that's an argument for making category a node rather than a property. So let's save our business here, and we have now our second entity, which is category. So I'm going to say we're going to have some nodes with the label category to represent the different categories. They're going to just have a name property that's specifies that their type of category. And we're going to have a relationship from the business to the category that's going to say something like this business is in this category. And this will allow us to do recommendation type similarity queries pretty easily. So let's quickly look through some more of these here. We have users. Well, that's certainly going to be another node label here. We have user ID, that's a string. We have a name, that's a string as well. Also important to note here that users have friends, so there's some social network inferred here. So user could potentially be friends with another user. So we've identified another relationship type here. Now we skipped over reviews. So here are reviews. Reviews are specific to a user in business. So I go somewhere for breakfast, I write a review of the restaurant, and that's what this represents. And there's some text associated with that review, and there is a rating. In this case, it's called stars, which is an integer, my rating for the review. Now, here's another great question. Should review be a node or a relationship? Well, typically, if you think of something as an event or a transaction, typically you want to model that as a node in the graph rather than just a relationship. In this case, I think this also makes sense because we have the text here of the review. We potentially might want to do some interesting natural language processing things on the text of the review. And if we do that, we may want to enrich the data model to maybe add entities that we've extracted from the text of the review. And if we do that, we can now create a relationship to that review node if we model it as a node. However, if we chose to model review as a relationship and we stored the text of the review as a property on the relationship and we did some entity extraction, well, we can't have relationships to relationships, so we don't have any way then in the graph modeling sense to enrich that review. So for that reason, I'm going to say that we want to model review as a node. It will have a review ID. It will have stars as a property. That's going to be an integer, and it will have the text of the review. And it's going to be connected to the user. So see here we have the user ID of the user who wrote the review. So we'll say user wrote review, and then a review is a review of a business. Okay, so this is roughly our data model that we can work with today. So let's grab a picture of this and switch back to our deck here. And we'll fill this in, and great. Now we have a data model. So we're going to model businesses, reviews, users, and categories as nodes and relationships that connect them. So this doesn't quite cover all of the data, but this is roughly a good start. So we have our data model. Now we need to figure out how to load this data into Neo4j. So we saw that, okay, we're working with JSON files. Well, surely there's just some procedure function in Neo4j to suck in JSON files and just create those using Cypher, which is the query language that we use with Neo4j. And there is. If you've ever seen the APOC or the awesome procedures on Cypher library, it includes a load JSON procedure. If you're not familiar with procedures, procedures are a way of extending Cypher. And if you haven't seen Cypher before, that's okay. We're going to take a detailed look in a moment here, but just at a conceptual level, I want to talk about procedures. So Cypher, which is the query language that we use to work with data in Neo4j, can be extended with procedures and functions. APOC is a library of those procedures that allow us to do that. So in this example here, we're defining some URL, then we're using the APOC load JSON procedure to fetch the JSON from that URL, parse it, and then it gets passed into the rest of our query, which we can then work with that JSON data in Cypher. Well, if you remember from the data dictionary page on Yelp, we don't really have JSON. What we have, let's take a look at the first few rows here. Let's look at review. So what we really have is one JSON object per row of this file. This is a format called streaming JSON, which is useful for working with large data sets because unlike regular JSON, which is an array of objects, we don't have to parse the entire file to work with streaming JSON. Instead, we can just work with it one row at a time, one line at a time. But in order to work with JSON in APOC, we need to convert the streaming JSON to proper JSON. One way we can do that is using JQ, which is this command line tool. So here, as an example, we're just grabbing the first 1,000 lines from the user file, piping it to JQ. This is a streaming flag that says we're working with streaming JSON, and just convert that to regular JSON, which we're then going to store in this user.json file. So if we do that, here's an example of just a simple script to iterate through all of these Yelp dataset files and convert them to proper JSON. And if we do that, we end up with with files that look like this. So here's our user. We have user ID, name. Friends is this array of user IDs, and we can see similarly the data we have for business that we already looked at, and also for reviews. So we can now we can pull this data into Neo4j. So let's switch over now to Neo4j. And so we can pull this data using APOC load JSON. I just pointed at this user.json file that we created, and let's just return the first 10 rows. So I'm going to run this, and we can see what we get back is this map or this dictionary from parsing this JSON. So we can see we have keys and values that map to the JSON object that we had in our file. So we can use this in Cypher, right? So we didn't create any data there. We just returned the first 10 rows to see what we were working with. But we could use the merge or the create statement in Cypher to actually create data from this JSON file. So for an example, this would create user nodes for each object in our user file. If you haven't seen Cypher before, let me just give you just a brief sort of overview of what's going on here. So Cypher is all about pattern matching. So let's switch back to Neo4j, and we'll look at this in the browser. So Cypher is all about pattern matching. And we define graph patterns with this sort of ASCII art. So nodes are within parentheses, properties are within curly braces, and in this case, this is a merge or an upsert. We could also say create here. So for each user object in this user.json file, create a node with the label user, set the user ID property on that node. We alias this node, so using u here, that's an alias that we can refer to later on in the Cypher query. In this case, we're just setting some more properties. So we can run this. we added 1,000 nodes because we were just looking at the first 1,000 objects in our file. Now here's something a bit more complex. We can do this now for businesses. So, oops. So this query, similarly, we're merging to create a business node, setting some properties. But now remember we had this list or array of categories that we wanted to create. Remember, if we go back to our model here, we wanted to create a node for each category with this in-category relationship from the business to the category. And we can do this by using unwind. So unwind essentially iterates over a list or an array, executing whatever's down here once for each of those elements in the array. So now we're merging or upserting on the category. Merge allows us to avoid creating duplicates. So if we see the same category name over and over again, rather than creating a duplicate category node, we'll just match on that and then create a relationship from the business to the category. So this allows us to create some more data. Now, if we take a look here, we can see, let's look at some businesses. So here's Pancake House. We can traverse out and see that, okay, it's a restaurant. It's also in the category breakfast and brunch. We can see other restaurants that also are in the category of breakfast and brunch. So if we're just wanting to do a very, very simple sort of similarity recommendation, if you like Pancake House, well, you might like Honeybee Hive's restaurant because it's also breakfast and brunch and a restaurant. So you can see how we can start to define these graph traversals that may find us something useful. Okay, so we can do this with APOC load JSON. I won't do the reviews, but you get the idea of how this works. Now, as we alluded to earlier, there's a problem with working with JSON with a very, very large data set, and that's this problem that we have to parse the full JSON object before we can work with it, unlike CSV format. So with CSV format, we can just work with a single row at a time and sort of stream this data. So Cypher has what's called load CSV tooling built into it, similar to this APOC load JSON that we saw. It allows us to parse a CSV file and pass those objects directly to the rest of our Cypher statement. So I wrote just a really simple Python script to convert our streaming JSON to CSV. So for each of our JSON files from Yelp, we just convert each line to CSV. I guess the only interesting thing going on here really is that in the case where we have a list, so for example that list of friends user IDs, we convert that to a string that's separated by a semicolon, which we can then use the unwind operator on to iterate over that list. So once we've converted those to CSV, well, what do those look like? Well, here's the review CSV file. So we have one row. That's our headers. So we've grabbed so this is for the reviews. We've grabbed the stars of the review, the user ID. There's an ID for the review, the text of the review, and then the business ID. So one line in the CSV file for each review with these headers. And we can now use load CSV to import some data into Neo4j. And here's my sort of what I'll say is the naive initial approach that we might take. Well, we grab this reviews.csv file. We know that we have a business in there. We know we have a user. We know we have a review. So we use merge to get or create the business node for this review. We use merge to get or create the user. We do the same for the review, and then we merge to create some relationships. And this would be fine for a smaller data set, but reviews has 4 million rows in it, and this is not going to be the most performant load CSV script. So let's see why that is and how we can write something that's a bit more performant. Well, the first thing we want to do is break up our merges into multiple Cypher statements. So the problem with this, or I say one of the problems with this naive import statement, is that we're doing multiple merges, so multiple upserts in one statement. And oftentimes the Cypher compiler is not able to really generate the best execution plan, or it's possible that we actually need to load everything from the CSV file before we can commit it, before we can figure out what the next operation is going to be. So for that reason, it's best to have one merge, if you can, per Cypher statement. And in this case, well, we have a business CSV file, we have a user CSV file that defines the users, so we can just iterate through this business CSV file, create all of our businesses, then in a separate operation, create all of our users, and now when we're ready to create our reviews, we're matching on existing users and businesses, and then we're just creating our review node and a few relationships. So this is going to be much more performant than our initial naive approach because we only have one merge or upsert per statement. But it's not quite perfect. If we look at the execution plan, so let's go back into Neo4j here. I'm just going to delete everything, so match on everything, detach, delete, and let's take a look now at, here's our load CSV for a business. So really simple, load the business CSV file, create our business nodes, and set the name. And on any Cypher statement in Neo4j browser, we can put this explain keyword at the beginning, and if we run that, it won't actually execute the query, but instead we'll get this nice visual execution plan for the query. So this is the series of operations that Neo4j is going to execute for this query. And if we're trying to make the most performant import, one thing we'll notice here is that our first operation is a node by label scan, followed by a filter. And the reason this is a problem is we rarely want to be scanning nodes. Instead, we typically want to use an index to do an efficient initial lookup. So while we're talking about indexes, I think it's worthwhile to talk about how Neo4j uses indexes. So in a graph database, you typically use an index to find the starting point. You find some initial node, find some subgraph to very efficiently start there and then traverse out. And each traversal operation, so following a relationship from one node to another, does not use an index. That's where we use this idea of index-free adjacency. where we don't have to hit an index to do that traversal. It's a constant time operation, which means that local graph traversals are going to be much more performant for local queries than if you were to, say, compare that to joins in a relational database, where a join is, in a relational database, is a set operation. You're using an index to find where two sets overlap. So just to be clear on how we use indexes in the graph, we use it only to sort of find our starting point. Now, we were using merge, and we said that merge will take a graph pattern, and if that pattern exists already in the graph, it will match on it. If it doesn't exist, then it will create that graph pattern. And in this case, our pattern was a node. So we were merging on the business node, treating the business ID as a unique identifier. And that's good. That's what we want to do. We want to merge on unique IDs or merge on keys. But we always want to make sure when we're merging on a unique ID that we've created a constraint. So a constraint allows us to define some data integrity and say, okay, for the label business, we want to assert that business ID, so the value of the business ID property on any node with the label business is unique. We don't want that to be repeated because business ID is the thing that uniquely identifies a business. Now, when we create those constraints, we'll also get an index along with that. And index is used by the database to enforce the constraints, but that will also give us more performance lookups when we do our merge. Now we can also create indexes without creating a constraint. So let's take business name for an example. We can have multiple businesses with the same name. So we saw Pancake House. I'm sure there are more than one business with the name Pancake House in the Yelp dataset, and that's fine. We don't need to create a constraint on that, but we do want to create an index because we may want to look up businesses by name as a starting point. So when we create our constraints, we'll see that now, if we look at our execution plan again, we'll have this node unique index seek instead of a scan, which is going to be much more performant. One other thing I want to mention about load CSV is this concept of periodic commit. So Neo4j is a transactional database. That means that every statement is either committed in its entirety or none of it is committed. And that's useful when we're doing operational workloads, say like storing some financial transaction, but it's not necessarily so important when we're doing import. So for that reason, we can get around the transactional nature of the database with this using periodic commit command. So what this means is that every, in this case, 20,000 rows, we're going to commit the transaction and start a new one. This allows us to avoid building up a lot of overhead in memory and allows us to complete our imports more efficiently. So you may have realized that we have multiple statements. So what we're going to end up with is sort of a script where we're creating our constraints. We have multiple Cypher statements. How can we run these in Neo4j? Well, Neo4j has what's called Cipher Shell, which is a command line tool that allows us to run Cypher statements, and we can pipe a Cypher file into Cipher Shell that will then execute each semicolon delimited statement in its own transaction against Neo4j. If you've seen Neo4j Shell previously, Cipher Shell is the new version of Neo4j Shell. Cipher Shell uses the Bolt protocol and has some new features which make it a more modern way to run multi-line Cipher statements in Neo4j. Now, it's worth pointing out also that load CSV and Cipher in general is typically single-threaded, but especially in the case of an import, we may want to do operations in parallel across many threads, right? So my computer has more than one core. I should be able to use all of those when doing an import. And so that's to say that typically one Cipher transaction operates on a single core, but I can run many Cipher transactions concurrently across different cores. How do I do that in an import? Well, we can again use a procedure rather in APOC. In this case, APOC periodic iterate. What does this look like? So periodic iterate takes two Cipher statements. The first one, in this case, is a load CSV statement. So we're loading our business CSV file, and we're just returning every row. And whatever we return from the first Cipher statement is then passed as a parameter to the second statement. And that second statement is then executed in batches with results from the previous. And we can control the batch size. In this case, we want to specify that, yes, we want to run these batches in parallel. And we also have this handy retry option. So we may, especially when we're doing parallel write operations, we may run into some locking, some deadlock exceptions. We can configure periodic iterate to automatically retry to execute that statement a few times. So this is really handy, especially for doing initial imports or graph refactoring, where we need to update, say, millions of nodes. We can do this very quickly in parallel. So in this case, we had 144,000 businesses. If we ran it with a batch size of 10,000, then we ended up with 15 batches that executed in parallel, doing parallel writes. So that was very, very fast. Okay, so while we're talking about fast, let's now look at our next tool that we can use for data import, which is the Neo4j Import tool, which is sort of like a supercharged version of load CSV. So load CSV, it works fine for imports, up to, say 5 to 10 million rows. But when we get beyond that, we typically need to use the Neo4j Import tool, which is a very, very performant way to do initial data loads. While we're talking about things that are supercharged, I want to give just a shout out to my colleague Max, who has a great blog. He's very interested in performance and really showcasing where we can make Neo4j scream. So if you're interested specifically in that kind of stuff, I would definitely check out his blog. Anyway, back to our Neo4j Import tool. So this is a command line tool that, as we said, is only used for the initial import only. It creates a data store, and it expects CSV files in a certain format. But as you can see from looking at this output of htop, we can utilize every core on our machine to very, very efficiently execute these imports. So let's look at just a simple example here for the case where we have users who wrote a review, and that review is going to have a stars property on it. So what CSV format do we need for Neo4j Import? Well, we have a few options. This is the standard approach. So we have one CSV file for each label. So we have a CSV file for all of our users, a CSV file for all of our reviews. We then have a column that acts as an ID column for user and review, one for the label, and then the rest of them are treated as properties. So on our user, we're going to have a name property. On our review, we're going to have a stars property. And then one or more CSV files for our relationships that have a start ID, in this case for user, and an end ID, in this case for the review, because we are saying that the user wrote a review. Again, I wrote just a simple Python script to parse these Yelp CSV files, parse the Yelp JSON files to create CSV files in the format that we expect for Neo4j Import. So if we run this, we can then use Neo4j Import with this Yelp data set. And here's what the command looks like. So we say Neo4j Import. We specify some directory for the database that we're going to create. As we said, it creates a database file store, and then we specify the CSV files that contain nodes and the CSV files that contain relationships. It's worth pointing out that Neo4j Import is now included in the Neo4j admin tool, which also includes tooling for dumping and loading data stores. And here's just to give you an idea of what this looks like when we run this. We go through some processing of these CSV files. There are a few different operations that occur, but at the end, it tells us how many nodes and relationships and properties we've created. So if we run this, we end up with about 5 million nodes and 38 million relationships created in about 6 minutes. It's interesting to point out that if we exclude the friends relationships, because there are many highly connected friends in there, we can get the import down to just about a minute. Okay, and so that, as I said, creates a Neo4j database file store, which we then just have to point Neo4j to. So depending on how we installed Neo4j, if we're using the desktop app for Neo4j, we just hit choose and point Neo4j to that yelp.db database directory that we just created. If we installed Neo4j with, say, the Debian package or the tar package, well, then we can edit neo4j.conf and say dbms.activedatabase is yelp.db, and then restart Neo4j, and we'll load from the data store that we just created. Now, it's worth pointing out that Neo4j Import does not create any indexes. So we want to make sure that we create our indexes after we fire up Neo4j, and then we can verify that in the browser with :schema. So :schema in the browser will show us the status of our indexes as they're being brought online. Okay, so that covered some APOC procedures, load CSV, and the Neo4j import tool. But we can also use the Neo4j language drivers to import data into Neo4j. So when you're building an application, you're not using Neo4j browser or running commands through Cipher Shell. Instead, you're using some language, some framework that's sending Cypher queries to Neo4j. And we have Neo4j drivers in just about any language that you would want. Let's take a look at the PyCon driver for Neo4j. So for a simple example here, using Python Neo4j driver, we instantiate a driver object that contains the connection string to Neo4j. And in this case, we're going over the BOLT protocol, which is the binary protocol for Neo4j. And let's say we just wanted to run a single statement in Neo4j to create this business. So we have here business object, which is in Python a dictionary, a dict, with business ID, name, city, state, and then some categories. Now we can pass this this dict to our Cypher statement as a parameter, and then create our business, unwind over the categories, and so on. And we run this query by calling run on a session. In this case, we get the session from the driver. So that's sort of the simple way to do this import. But what if we wanted to read from the business.json file, which has the streaming JSON, and we wanted to import all of that data? Well, one thing we could do is execute over each row and then run a statement for each row in the business JSON file. But there's a problem with this here. Session.run will run our statement in a single transaction, which means we're going to run a single transaction for every line in our business JSON file, which is not what we want to do. There's a lot of overhead involved in in running these in a single transaction, so that's not going to be very performant. Instead, what we want to do is do these in batches. So we can begin a transaction for our session, and then as we're parsing the business JSON file, we can append each statement to that transaction and only commit the transaction, say, every 1,000 or 10,000 lines that we've read from our JSON file. And that's good. That's better than certainly executing each statement in a single transaction. But we can also use unwind here to, again, operate in batches. So what we're going to do here is we're going to iterate over our business.json file, and we're going to create a list now of dictionaries, and we're going to pass that list in to our Cypher query and use unwind to operate over this list of businesses. So this ends up doing these creates in a single statement. So we save some overhead there of processing each statement, each Cypher statement. But we're still operating in batch because we've batched our parameters into a list. Now again, as we said previously, we're operating in this case single-threaded, but it's often the case where we want to do inserts in parallel. Now, to do this in Python, we can create a queue, and we can set the target of multiple threads to execute our Cypher statements in batch. So what are we doing here? Well, we're iterating over our JSON file, creating a list of parsed JSON dictionaries. And then once we get to 1,000, we're putting that list on a queue, and we have 16 threads that are grabbing lists off of the queue and running these insert statements in parallel. Now, the only problem with this is that we sometimes may run into deadlocks here where we're doing lots of write operations in parallel. And so, so for that, what we can do is we can retry retry this operation a couple of times. So we check to see if we've tried this this specific list of items previously. If we haven't, we put it back on the queue. If we have tried it and it gets above some retry threshold, then we put it into a single-threaded queue, which we then run after our multi-threaded queue is finished with all of its jobs. And again, that was going through that pretty briefly, but again, all the code is online. So those are some different ways that we can import this data into Neo4j. Hopefully, going forward, we'll have another chance to look at, now that we've imported the data, what are some interesting things we can do with it? Can we infer some of these social graphs? Can we generate relevant recommendations? Can we use some of the spatial integrations in Neo4j to work with this data? So if you're interested in learning more or getting started with Neo4j, there's this great tool which is the Neo4j Sandbox, which allows you to spin up Neo4j instances with a specific data set loaded around a certain use case. So anyone can use this. The one I think that's most relevant for what we talked about today is the recommendations sandbox. So this has a data set of movies and user reviews of movies with some specific guides that show us how we can write Cypher queries to do, say, recommendations using cosine similarity and things like that. Great. So so we're about out of time, and that's all I have for today.
Excellent. Thanks so much, Will. And thank you, everyone, for joining us. We are just about a minute over time, so unfortunately we won't take any questions live, but you can feel free to reach out to us via email or reach out to Will directly. And with that, we'll go ahead and send out the slides and the recording, so check your emails on Monday, and we hope you have a fabulous weekend.